Hello, my name is Randy, and I'm giving a commentary on vector source code files as I go through them. I've been looking at the face and eye code. Specifically this time we're going to look at how the eyes are actually drawn or rendered, the multiple passes that they go through to add in the shape and its roundedness, and then optionally given some noise glitches and scanline, which are not enabled in vector, but are probably present from Cosmo and might someday be something that somebody can try experimenting with. Let's look at the proceduralFaceDrawer.h file. Unlike the other header files, it doesn't actually have a comment block at the top. It has the usual boilerplate kind of stuff up here otherwise for the protecting against multiple includes and the include headers. Interesting note on the forward declaration, it has something here for the tracked face. This must link in something that uses this into probably where the eyes should look to look into somebody's face and gaze at them. Now what you see here in the namespace is it has Anki, it has vector, but it does not have anim this time. It could be that the anim development side was done differently than the side that actually developed, the team that developed the face, and they maybe didn't agree on the namespace for that, or it could have been some other quirk that led to that. But it's kind of interesting that this only has a 2-level namespace while the other parts had a 3. But really what's most interesting is this really nice comment block here. And what it's describing is that the face, when it draws the face, it goes through a series of steps, and each of these steps is modified by the next step. And what's also interesting is that they might cache the results of one of these steps. So maybe the shape of the eyes change so that it gets drawn, and then they have the various effects that go on top of that, including the noise, hotspot, scan lines. And then when it comes back later on, maybe the eye hasn't changed, but some of the noise randomness has changed. So it reuses the earlier cached value from that drawing those eyes and changes the noise drawn on top of that, or changes how the scan lines are done. I don't know if that actually saves anything in the end. I don't know if that is so expensive that it's worth the memory pressure to cache that and manage all of that. But they must have thought it was worth setting it up for that, at least in the Cosmo timeline, if not in the vector. So let's kind of look at the comment here. It says the face rendering pipeline consists of stages, each depending on the previous stage, such as drawing the eye, transforming the face, adding scan lines, distortion, noise, with the final image being converted to RGB 565 texture to be sent to the robot. Each state in the pipeline consists of excuse me, try it again. Each state in the pipeline follows a similar path. Did an earlier state change the input to the stage? If it did, this stage must render and clear the surface. Don't know what they're referring to as a surface. That could be that frame buffer that it's working with in this one particular spot. Clears that out and updates it. Or it could be something else. If the earlier stage did not change its input, compare the latest face data with the face data used to generate that cache one, and see if that has changed and must be redone. Then it will render this stage. It updates the cached face data with the latest face data, uses the face cache for the previous stage's input, assigns a face cache for the stage as output. So someplace to store that, the results of this, and then apply the steps it does here. Don't render this stage. So if it's not rendering this stage, okay. Leaves the cache face as it is, and then takes the input from the previous stage and passes it on to the next. So a key concept here is passing indices into the cache for inputs and outputs, such as if there is no face transform, then the input to the noise stage can be the output from the eye stage. This is an alternative to the face transform performing a memory copy from its inputs to its output. All surfaces except I8. I don't know what that means. So it's integer 8, but not real certain what they're referring to. Except the final upon which the last stage is converted from V, constant H and S and V. Okay, I think I see what they're saying. So normally normally it draws basically in grayscale, which they're referring to as I8 or V, and then it adds in the color for the eyes, this constant hue and saturation, when it converts all of that to H65. Okay, that makes sense. The code for each stage is kept largely as the original. The scanline distortion has been changed from modifying the input image to generating a new output image. This allows eye rendering and face transforms to be cached. Scanline distortion applied to the original output rather than a face that has already had scanline distortion applied. Similar for the noise. And then apply scanlines is a special case as it is part of the public API and used elsewhere as its functionality has been retained and does not affect the cache. So there's some questions I have here, but I don't know if we'll ever know the answers to them. We'll look into the code and see what it does. I do initially have some curiosity because the screen isn't that big, and I wonder if at the frame rate, if all this caching is always as valuable as they're thinking. Maybe not. Close eyes and switch interlacing. So this is get the next blink frame. So it's going to close the eyes, update the that scanline interlacing that we see, and they say to call this until it returns false, which indicates there are no more blink frames and the face is back in its original state. Oh, okay, I see what they're saying. So we call it with the time step, and if that's true, we'll keep calling this in the next update, and then when it returns false, we'll exit the blinking phase and go back to what we were before. Procedure to draw the face with the current parameters. Apply scanline. So this looks like yet another one of those methods that handles the calling the scanline filter, which adds those Cosmo-like eyes. So it's interesting. It looks like here they want the input buffer to be hue saturation value, not grayscale, but they actually want it to be some sort of colored buffer when they do the work on that setup. We'll have to keep that in mind. Then drawing the eye, which takes this HSV and then looks like it probably does. Yeah, it takes the individual eye, where it's at, its location, how it should be tilted, and all of that, and does the items. I suspect the transforms and and some of the other aspects begin to add up. That may have been their concern. So here's the data structure that they use to cache the face at that individual stage. So they have basically a frame buffer here for the grayscale image, and then some information about what's in it. It looks like, and whether that's distorted, final, and so on. Interesting here, they have some bounding boxes for the eyes. Don't know fully what the column and row mean for the face there. Interesting. The procedural FaceDrawer C++ code is by far the largest file we've looked at so far. It's got 1,100 lines of code in it. Well, 1,100 lines, depending on how you count code. But since there's few comments, it's pretty dense code. So again, like the header file, it doesn't have a comment block at the top, so we don't really know how old this is. But we can probably guess pretty well. It does date back to Cosmo based upon a number of factors, like the effects and other items. What we see here is kind of interesting. What they have is, okay, array 2D, that's probably how they're going to store the frame buffer, but we have the matrix, quad, and rotations. That's probably the transforms and visual effects. OpenCV is going to be used here for some image processing. I don't exactly know what high GUI is or intended to do, but the image processing is probably going to be related to the noise and the gradient, Gaussian gradients and other aspects that are used to give it a shape, the eyes a shape, and do the hot spots in them. So yeah, so starting off here at the top, they define a macro here, which is just a helper to do rounding. I'm not entirely sure why they just didn't use C++ using standard and just use round. Why they just went with the full round there. That That's not real clear to me. Perhaps they were kind of concerned about pulling in too much of the other standard namespace and conflicting with other items. They also have a casting helper here, which is not immediately obvious because it doesn't look clamped so much as it just cut off, because they commented out the code here that does the clamping. Probably some sort of interesting tweaks along the way where they started off with trying to do a lot that was as correct as possible, then scaled it back to what was sufficient. Yeah, they have a type of filter, so so different kinds of filters, I guess, that they can apply to the image, and it looks like it's probably going to be something that can be set using the console on the web tool. So here it goes. Here they're defining a bunch of the console variables, how they draw lines. So I believe that they draw a line around the eye's edge to kind of help define the edge nicely, but no guarantees there. Interpolation type, interesting. That probably, typically these kind of interpolations are if you scale an image, so we'll have to see what they do on scaling there for how they use interpretation. Same with the delta. Some factors there which will probably just affect how the eyes are drawn. The hot spot, I guess, how tight that pupil is and how much it falls off is what I believe that to be. And then anti-aliasing, again, that's probably to make the lines less jaggy, although it might be done to the filtering. Does say anti-alias filter here. We'll have to kind of see. If the glow feature is enabled, which we saw in some of the other files, it doesn't appear to be glow enabled. That, I believe, that kind of adds a glow around the outside of the eyes. This kind of adjusts that factor. And then if the scanline feature was enabled, this is parameters that could tweak it from the web console. And same for procedural noise. I don't recall if that's enabled or not. I believe it isn't, but it looks like they can add some various amounts of noise in there. It doesn't really indicate a lot in the way of glitching, just so much as just how much noise they add. And then we get into the parameters that kind of define the face. The shape of the eye, some buffers to draw in. So this procedural face draw or glow image. These look like frame buffers to hold it. They call it working surface. So this must be the entire grayscale kind of working surface. And then a cache to hold the different phases of the image drawing. And then some parts here for the different bounding boxes. I don't know all that they do, but we'll kind of dig into that. So transform matrix, this probably is used to rotate, tilt, and move the eyes around, and then change their how big and small they are. It is looks like just a classic affine transform where they're just doing it for 2D and not doing the Z dimension. Yeah. So we can't use the one in OpenCV because it only incorporates one scale factor. Oh, they want to change a separate scale factor for the X and Y to make the eyes bounce bigger, wider, or taller independently of each other, which makes kind of sense. Here they're doing, so an exponent, that's probably relates to the Gaussian filtering for the blurring and the cutoff. And there's a bunch of different ways of doing it quickly. They're using floating point, and so they're just using a simple equation to emulate this, and they just converted that to the terms of using Taylor's expansion from basically a freshman college calculus. So here's, if the noise feature is enabled, there's way here they're going to create the noise. They talk a bit about here using the features of the processor, this neon capability. So that probably they made some effort to make this fast on vector. I suspect that this neon performance probably isn't available under Android devices and iOS devices, I believe they have different acceleration APIs, but I don't really know a large amount of that. So they're getting a noise image, they create noise image, so they create several of them using different random numbers. And not fully sure what's going on here. There's a lot of bits we have to guess at. So they kind of, it looks like they might change the noise over time, and they check to see if the web console here changed the amount of min and max lightness and perhaps recalculate the noise images. That's kind of hard to tell what might be going on there without spending a lot of time just working this out by pen and paper. They have a procedure here to apply anti-aliasing, which kind of takes off the jaggies on any sort of the curves and lines, I bet. And they do this by blurring. Look, so that's a really nice technique for smoothing off edges. If it's on text, it can make it look blurry, but there's no text here, so it looks really good for the kind of things that they're doing here for displaying an eye. And here is the eye code, which is we kind of got a hint of what this might look like with the PyCosmo software that was written. I forget the name of the author, forgive me. But here they actually have a lot more detail that we can look into. So they have the corners in the upper and lower upper left corner, lower left corner, upper right, and they kind of used that to figure out different parameters and how they're going to shape a polygon around the eye using that. So, and then they're basically using a series of OpenCV calls and using the OpenCV tools to connect them together. And it will let OpenCV merge those different image pieces together into one overall polygon. So and then here's the lower lid polygon as we go along through that. We have several checks here. I don't know if these are checks that could be used by somebody wanting to check the animation file that they're sensible, or if it just happens to be a lot of calculation that's very specific to the way they are computing the shape of the eye. So now here we're in the upper eyelid. And then down here we have the matrix. So let's see what we're going to do with that matrix. I bet you we're going to rotate and move it around. Yep. So they're going to rotate and move that eye around, and they have different scaling factors for how much that eye is going to stretch wider or taller, and then the angle they're going to tilt that at. So that can give the eyes the ability to bounce around nicely. Then here they add the ability to add glow for the eye. There is a transform that they're applying to it, glow fraction. I don't see though anything which would do the glow other than just transforming it. I wonder if that must be used below somewhere later on in a later step. They're preparing it here, must be. So wrap the poly and the glow. Use the warped glow, which is a larger shape, to compute the overall eye bounding box. Okay. So they're going to compute the bounding box for the glow if that's what we're used. Otherwise, they fall back to the tighter eye. They do some warping of the eyelids. Don't fully know what more they have to do on that. Interesting. They have some attempt here to fix some noise problems, which is from the math accelerator that they're using. And then they draw the eye. I'm not real sure how much they need to have that clipping region or not. I wonder what would happen if they just let it go anywhere on the screen, because sometimes that is not really all that important. It just, maybe they need to clip it so that the toolkit works correctly if it wraps around the edge of a screen. I'd be kind of curious to know how much they need to do that. Otherwise, the eyes are typically just, they don't overlap and they aren't layered on too much. So black out the lids here. Let's see here. So yeah, they're using a polygon to handle the lids that kind of curve up into the eye or curve down from the upper eyelid or up from the bottom on the cheek. Here they're going to calculate a hotspot center. This is kind of a cool effect, I think. They compute where it glows and how wide that glow is and falls off, and they got some math here to do that. They call it compute the 2x2 inverse matrix for the Gaussian fall off, incorporating the scale and rotation. So it's interesting. They draw everything. They come up with the polygon shape and then transform that and then draw that transformed shape, as opposed to perhaps the other approach, which is draw the shape of the eye, knock out the eyelid and cheek, and then rotate that image. So they must have decided this was a better way to do it. Either it looked better or it performed better. But yeah, here's the hotspot center. And hard code this, fast exponent cast. And it looks like here what they're doing is they have a for loop. So they wrote custom code to draw this. They're not using a filter on top of this to draw some sort of shape. That they actually are drawing a Gaussian blob, really, for the hotspot, because the center is the brightest, and then it has a fall off, and then they just draw around that. proceduralFace glow. Remember, this is all one method, and we're 500 or more lines, and to really mostly just one method here. So if we take off the first few hundred or so, this is 400 or so lines. Eye bounding box for the glow. It looks like they're probably going to, interesting. Now, my guess was that they were going to draw the glow as basically take the eye as a plane shape before they added the hotspot. Take a copy of that, widen it out a bit, and then by blurring and do a little bit of other aspects to make that kind of create a glowing effect, and then put that original eye back on top of it and add the hotspot and other shaping. But that looks like they're doing this a later step. I'm trying to read through here what they're doing. So they got a glow lightness factor, a multiplier, some math to kind of scale this. And and they just filter. Yeah, so they do filter the whole eye. So they're using, depending upon which type, you can choose a box filter, Gaussian filter, or the neon accelerated box filter, how they would choose to do the glow. So I wonder where that is. I don't think it goes on top. I wonder if that's in a separate layer here. They did indicate that each of these has a different drawing, what they call surface. So anyways, interesting comment here. Employ glow anti-aliasing after glow because it changes the eye shape, and we want to which we use to compute the glow above. Huh. Okay, so now here they're compositing all the pieces together onto the actual display buffer. So it looks like they're hinting that they're going to put the eye first, then add the outer glow, noise, and stylized scan lines. So let's see if that's truly how they do it. So they're going down each row to get the face image. They're getting the eye shape for that row, getting the glow image. And then they're going to go for each column in that. So basically they're scanning over each pixel. And so let's see here. New value seems to be where they're getting the pixel. So they're getting the eye. They are clamping that, whichever is greater, the eye value. Kind of curious because maximum of new value, which is from the eye value or eye value. I wonder if that has something to do with the casting there, because that would look to me to be a no-op. If that part of the eye is greater than the glow value, you're going to keep that eye and then just scale it by the lightness multiplier. Otherwise, they add the glow part. Interesting. I'm not super knowledgeable on this kind of image trick that they're doing to create that glow, but it probably makes sense to somebody who thinks about this for a bit. And then take that eye value and then change the lightness scaling factor, and then they're going to put that in the image buffer, but looks like they're going to make certain that it keeps whichever is the brightest pixel, what's already in the pixel, or the this new eye part. So it's kind of not blending the two, they're just kind of choosing whichever part has the brightest pixel. After they do all that, they're going to, looks like they're going to distort the whole display, I bet. I bet you they don't distort it tilted. I bet you they just makes it so that it looks like the display is the part that's distorting, not the actual eye. So, and if there's a distorter, they're going to add off noise. Now notice this scanlineDistorter call here isn't in an if-def, but we do know that this get scanlineDistorter method is, and will return a null. So it's interesting which level they chose to make those configurable parameters. Okay, let's go on to the draw face method here. Interesting. This is pretty simple by comparison. So it's going to go through here and apply each of the steps. It's going to draw the eyes, apply the scan lines, distort the scan lines. Interesting that it distorts the scan lines, adds noise to the image after it does the scan lines, and then converts it to the final color. So these are the 5 steps it would do, and checks to see if there's anything dirty about that. What it looks like here is this dirty variable checks to see if draws the eyes and sees if there was anything that was done to update this, or if it reused the cache, and passes that value into apply scanlines. So apply scanline knows that if its parameters changes, it has to redraw it. But it also knows that if its input of the eyes has changed, it has to redraw, which we saw in that comment in the header file. Same for the distort scan lines. It knows it has to redo everything if the input image has changed or if its parameters have changed. Same with noise, and then finally convert color space, which so I'm guessing a lot of the effects of drawing the eyes drawing them, let's see here, they would do this 24 frames per second, which is the fastest they could do it. And all those pixels, that probably was a lot on the, they felt that either saved CPU time, if the eyes weren't moving around very much, save battery life, save temperature. That's probably the main things. If they go to a bigger display, or we're considering a bigger display, is what they probably want to have that option that they could save space, or save that power and that heat and time on that, is my guess. And judging by all the profiling code, they had a pretty good idea of what was slow here. So here's that method to draw the eyes. Again, here they're checking the parameters to see if anything's changed. It's more of so this is a cache check to here. One of the hard problems in caching is to know when you need to change the stuff. So they check each of the values with the previous values. The previous values being held what's in cache, and see if anything's changed. Because some of these values are floats, they use this whole helper here to check if the values changed by much or pretty much the same, as opposed to being exact. That's the right way to do it with a floating point number. And then they update their dirty variable. The dirty is the one if the previous input frame has been updated, so that they would have to force it to draw it anyways. So so they're going to get the parameters to draw this, set all this up, and they're kind of storing these things in the cache structure here, using some setters and getters. It's using the setters. Let's see here. So it looks like they're clearing out, they're creating an image buffer here, or at least what I call a frame buffer, image buffer, and they're clearing that out. They're going to get all the transforms. Oh boy. Yep, so they're getting all that, getting all those set up, and then they draw each of these eyes. So it looks like the face transform is, so if the whole face is rotated, so it's tilting its head, and then they can perhaps rotate or scale the eyes individually. I'm gonna go double check that, because I feel like it sounded like they could rotate the eyes individually, which you'd only kind of do in a few animations. You wouldn't do very often. Yeah, they do offer the individually eyes. Mostly, they probably just scale it. I think the animations probably only have the eyes wibble or spin or have that kind of distortion only for cases where vector was shaken or explosions were going off or otherwise mental confusion, because you wouldn't want that very often for the organic look. But yeah, let's see. So if this matrix that small, and if they were careful, that wouldn't impose too much penalty, given how much they probably wanted to be able to squish and squash the eyes. So they call here each of the. So they draw. Now that they've figure out how they're going to tilt both eyes together, so tilting the head, and then they draw each of the eyes and let them each individually be squished and squashed using their input image from the cache. And what do they do here? So more of this to find out I guess the bounding box of the face. It may be that they're trying to figure out which part of the display has changed so that they can only transfer that part of the image buffer later on and reduce some memory copy or some SPI transfer to the LCD. And then they were finally returned whether or not they changed anything, or in fact the earlier stage changed something. So this is, these are, a good idiom for, an image processing pipeline to pass in this dirty flag and then check its parameters and kind of update like that. Although there might be a little bit of ceremony that can kind of confuse a newbie. So here's the distort the scan line, which we know that they disable. So they get the scanline distorter. We know it's null because they disabled it until somebody can compile a version where they can enable it for technical glitches in the eye. Let's see here. Let's read this note. Scanline distortion has changed from modifying the input to generating a new output. This allows the eye rendering and face to be cached. Scanline distortion to be applied to the original output rather than a face that has already been scanline distortion applied. I wonder when they made that change. I'm beginning to wonder if they made that change in vector more than they made that in Cosmo, but I don't really have any evidence one way or the other. So, here so they're doing whatever it is that they're doing to set up here. They're setting up the cache with a new image buffer or frame buffer to hold this distorted image. It looks like they're going to figure out how much they need to distort that image by to create the raster scan. And at some point, I thought they call it a helper procedure to do this. I'm mostly just seeing mem copies here to move things in and shift it around. These mem copies here. So faceline. Huh. So, interesting. It's I expected more use of that pointer to something that would be executed. When they apply noise, or at least have the option to, if the procedural noise feature is enabled and number of noise frames is greater than 0. I wonder what that number of frames means. So final phase. So again, they're checking the dirty flag here. Interesting that they're forcing it to be true. So they would pretty much, so if it was previously dirty, a previously cached one, they're going to zero it out, even though they just allocated it. That seems like a bug waiting to happen. They just allocated a buffer, And you know, it's convention these days for the allocator to zero things out, but they've been filling it with 0 anyways. Then if the input is dirty, they zero it out. But what if the input wasn't dirty? Because either way, they're going to do this. They're not reusing a buffer if they're allocating it. Anyways, assign a new face cache for the noise. The reason for the changes. If the eyes haven't changed, the face hasn't changed, and no scanline distorter. Then there is no work to do until the noise stage. So it looks like they were considering the idea of applying the noise individually to the eyes, probably because it was fewer number of pixels, and thought perhaps that would be less work and less impact on the system. So it looks like they thought in concept that the math accelerator in the ARM processor was going to do things in such a way that is performant that would actually make this better to do it on a whole frame rather than these individual smaller images because of all the memory transfer. So they're going to create a noise image here using a random number generator. And it looks like my bet here is they're going to just basically add the two together. Let's see here. So they get the eye shape from the eye cache and get a pointer to that. Now if it's ARM, which they detect here at the compile time, so if this were compiled on a different architecture, they wouldn't use this. I wonder what would happen if this wasn't on an ARM architecture, if this would even do the right thing. It looks like it would probably skip that step because whatever other architectures they were considering wouldn't have that code here yet for it, or was removed. So they're going to scan over each of the pixels in the display and do some sort of vectorized math. I understand the multiplication here. So they're going to basically get the pixel and they're going to multiply it by some noise factor, and they're going to make certain it doesn't get too big. And then they're going to send it back out. So it looks like the noise is multiplicative noise as opposed to additive. So they're just going to take some potentially random numbers and multiply them by the pixel value and get the new pixel. At least that's what I'm seeing here. And then they're going to go through here and then they just clean up the buffer so that it's in the right format after all that. And the final, what I think is the final method, they're going to convert from that grayscale to the actual, or perhaps they were already in hue saturation, but they're going to convert that to the final color space. I believe it was going to be RGB 565 at this stage. So they check to see if the inputs have done anything, and then they check to see if any values have changed. And then now they're setting up the hue and saturation based upon basically the preferred colors for the eye. I bet you that's where that comes from, is this hue and saturation traced back to whatever the preferred colors for the eye would be. And that may ripple through a few other systems that change that. So they do some things to make certain that the eye values are, these hue values are, and saturation values are in range to be used. And then convert final image limited. So they're only so the bounding box is used to make certain they're only going to modify the pixels that were actually drawn. So they're trying to reduce the work here, so that they don't scan over every pixel in the buffer. And I don't know if that actually saves anything or not, depending upon how you do that. That can save space. So they're creating a buffer there. It looks like, I don't know where this is coming from, this eyes ROI, get ROI, but I suspect that is a OpenCV method to do that and convert a scalar to a grayscale scalar to a one with a tinted with a hue and saturation. Before we look at the next method, we need to jump to the header file here, proceduralFaceModifierTypes.h. It has an important structure that we'll need to know about. this header is dated 2018, which would have been in Vector's development cycle. So this could have been created for Vector as a refinement of what they did in Cosmo, or it could have been what they call refactored. When they rewrote some of the code, maybe they moved it out from Cosmo. It has all the usual stuff in a header file. Again, like the namespaces before, it's only Anki and Vector. It doesn't have anim or animation there for a third level namespace. But where it gets important is this enumeration for the blink type. So there are four kinds of states that the blink can be in. The eye can begin closing, it can be closed, it can be just open from the closed state, and it can be opening. And then they have this struct here called blink event for the time, for a time point or a keyframe, and then what the state of that eye should be. Now, I was a little confused initially. I thought that it just went through 4 states one after the other. But as we'll see here, actually it can be it can have multiple entries for the same state at different time points, and that they can modify some other keyframe, some other parameters there with it. So let's go back to the C++ file. So here's the get next blink frame method. And what they'll do here is, then they have the blink parameters for this. I'm not real sure why they just didn't incorporate all of them together in the blink state and blink parameters, but they chose that. So they have here the width and height modifiers for the eyes, a relative timestamp, so duration of when this occurs, and the closing. So the closing is the most interesting one here, and if you kind of watch Vector blink, you can kind of see what's going to happen. So the eyes narrow, but the eyes don't change much width, and that's for probably 33 milliseconds or so. Then the eyes narrow even more, and the eyes get a little bit wider. So it's doing the squish and squash. Then the eyes get very narrow, and they double in size. And then when the eyes are closed, they're super narrow, and it's 5 times the size. So that's kind of what I was observing when Vector blinks, is the eyes do squash out in that way. And then when it opens, the eyes widen up a bit. The width goes to only twice the normal size, and then it kind of reverses the process there. It's not as 3/4 the size, but almost the same width, and then they get to the being open with that. And these states probably kind of impact how it probably draws the eyelid, the upper and lower lid. So as we go through here on this list that they template made. Now, by the way, this shape for blinking and animation, I think it's great. I really like the way it works, but it does lend a possibility that as people create custom software for Vector, that they might make this a customizable thing in a config file to give different more offbeat eyes or looks. So here they're going to go over the list of items. They're going to check the items and see that everything is kind of normal and link this up to the rest of the system. Here they're going to repeat the process for each eye. So they begin the iteration. At least that's what the ceremonial stuff looks like. And then they do this for each eye. They scale the left eye and scale the right eye by these width parameters and move to the next. And then the state, which is what we're looking at in that header file, comes down. And so if it's by itself, and when it's opened or opening, it just changes the width and height. But when the eyes are closed, it does something here to completely change the height of the eyes for both of them. And so that they kind of blink, and they're very, very different. So it kind of looks like they're moving the eyes in at a common height. And they say here that in case the eyes are at different heights, so the eyes are perhaps tilted because the face is tilted, get the average height so the blank line when completely closed is nice and horizontal. And then they get rid of, here they're saying they get rid of the eyelids there. And then when it's just opened, they kind of are reversing this process. And then the rest of it, the other 2 states again are the same. And the rest of this is just ceremony to copy these through to this output blink state in procedural face data. So. And then finally, the apply scan line. Nope, there's a couple more methods, but they both are apply scan lines. So they're checking here if the feature is enabled and that the enabled at compile time, and then enabled as a configurable parameter, and that the opacity, probably the opacity in the animation file or the in the web console makes sense. And if there is no if the lines aren't really going to be opaque, there's no point in adding the scan line. So they go through here, and then they just draw a line on the blue channel. Interesting. But they do have this should apply scanline to row method. I wonder where that is. And again, they have apply scanlines here, which I bet you is a very similar method. Again, doing the same thing, checking if it's compiled in, checking if it's enabled, checking the past value. And I don't see a lot here that I fully understand. So they're going through, they're getting the row, and they're setting the row straight out to 0. I wonder why there are two different buffers here that they're doing this to. If we saw this earlier, I didn't pay enough attention. And again, they're calling this apply scan line to the row, and they're just basically scaling the row down by this opacity value in both cases. So we saw that up here in the earlier one where they're scaling the line down by the opacity, so it doesn't have to be completely dark. It can be dimmed, so the rest of the eye can be bright, and this can make grayed out a little bit. And we see that here. Oh, I see what it is. I'm sorry. I see a little bit why there's this extra on here. So this is 0 and is 1. If what they're checking is, but like before, if it's near 1, they're just going to skip out completely because it's not opaque. If it's fully opaque, it's 0. There's no point even doing the math. They're just going to use a more optimized routine to set that whole row to black. These memset routines are usually customized by the compiler vendor for the micro or the micro vendor, so that it takes advantage of its memory pipeline and its word size and whatnot. So it does everything as efficiently as possible because it is often called. And so that is a look over how the eyes and face are rendered into pixels and bytes. Next time I'll look at the scanline buffer and see if that has a lot to say. Here is the scanlineDistorter.h file. I had anticipated this to be the transform, those methods we saw before, which make the alternating lines opaque for the scanline distortion. Actually, it says it holds the parameters for the distortion, which is a little bit more generic, sort of like the settings for it. And judging by the date, this dates back probably to Cosmo timeframe as they were working on that first. So we see all the usual good things in a file here. They have all the header stuff. They have a namespace, so they have a util namespace, vision namespace, vector. Again, they don't have this in the anim namespace, so I wonder why that sometimes used and sometimes wasn't used. They have a console variable that is used elsewhere that they're going to use in here, probably in this template that we see down here. I don't entirely know yet what this off noise max width is, but when we look into the method, this template method, we'll probably get an idea. So they have some declarations to call here. So add off noise given the warp matrix, which positions or scales the eye in the face, draw corresponding off noise into the image. So what it looks like here is that this for loop of off noise points. Now, it does not say what an off noise point is where I'm seeing here. That's interesting. Is that, oh, here it is down here. So it's actually a list of points that are defined on the eye. I wonder if they're randomly generated or they have a specific pattern. But so they're not going to generate noise all over the eye. They're only going to do it for a few points. By a few, it could be 100, it could be a dozen, it could be 12, like that, or it could be just a couple. But enough to get the little sparkly glitches, but not so much that it overwhelms the eye drawing process and takes away from the rest of the processing the vector needs to do if they enable this. So they go here and they get get a 3D point. Don't know why it's 3D. Oh, I know why it's 3D. They got the warp matrix here, and they're going to compute the point. So they have this warp matrix which tells how the eye has been shifted and moved and rescaled. And then they're going to take a position on the nominal eye. They scale that for the width and height of the eye itself. And then they take this warp matrix to kind of move that around into where that eye was drawn and can get that new point. And because of the way matrix math works, for affine transforms, they needed this extra dummy value. Some people might think that there's a way of shortening the amount of computations done there, but it looks like they were trying to make that trade-off of being understandable versus tighter, more performant code. So then they kind of, but only a little bit later here, then they check to see the width of the noise. So I guess the sparkle noise or this thermal noise, what I think of thermal noise or shot noise, the kind of old staticky noise that you would get on an old tube TV set or analog standard def TV. That's probably the width of those speckle patterns. They get us, and they randomize it using that max width from a range to 1 to something. And then they just kind of go through the pixels in that width and zero them out. They don't, this isn't an opacity thing. They just zero them out to make them dark. If that width is 0, they just zero out a single pixel. It looks like down here, they also have a shape of control points. I don't know what control points mean necessarily for the noise, but we might find out. But it looks like there's a variety of different things that could be tried if the scanline distorter was enabled. So they have 2, 3, 4 different control points that could be used to set up the noise. So let's see here. We got the C++ file here. All the usual header stuff. Again, it's namespace. They got the console variables, which is what we were looking at a little bit before this. Right here, this is what we're looking at. You also have a fraction of the eye area to be off. Don't quite know what they mean by off. And amount to shift left, right per scanline. Okay. So they have a random number generator here for noise, of course. And then so they have a scanline distorter. So they're given the maximum amount of pixels, the probability of noise, and then it looks like this shape is randomly chosen for the distortion. It actually isn't a configurable parameter. They randomly choose this based upon the number of ones defined, and then they choose the, looks like the shape direction. So could be possibly how they move the points around. And so depending upon which one of these it chose, it computes some control points here. There's a lot of ceremony in this, but it looks like they're just random points that it chooses, with some weighting, especially as we get into the triangle and curve spots, which have 3 and 4 control points. They have a little bit more weighting on what they might randomly choose over. So midpoint and back. And then it looks like they check sensibility here. It's not real clear what the control points do yet. Maybe we'll find out as we go down. So as they update going along, they have the control points. They have the direction that the control points are moving along as, and so they compute another random number, and they just shift it. Okay, so that just shifts the noise around. Okay, they get the eye distortion amount, eye fraction, looking over the control points again, and some portion between the top and the bottom of the eye. and they're getting distortion amount there. So they're just getting the number of pixels that distort randomly based upon that. Not fully sure what's going on there. This looks like to be more interesting. So they have this next distortion frame. They have a whole table of probabilities of which they probably cycle through and choose. So they remove the scanline. So okay, so if they're resetting, they remove the scanline distorter, begin the distortion amounts begin, which are these. And so they're going to go one by one with different amounts of probability of distortion to kind of create zzz and hissing and kind of basically kind of a noise, which is very clever. I suppose this could be customized too, but I don't fully understand enough yet to think about that. And then they increase the distortion. I don't really see how they're computing the points where they distort the face yet. I guess I missed that. If anybody finds that out, let me know. I probably stepped right over and didn't catch it, but it looks like here, when they get the distortion frame, they are calling a distorter and updating it. So they're just, it looks like they're just updating this part up here. I don't really know. I guess this file is going to remain a mystery for me for a little while, especially since it's not fully used. I don't know quite